Okay, our last equation, we derive this equation, the last equation, this one. Here this is the torque and total torque acting on the system, and this total torque acting on the system is basically equal to the rate of change of angular momentum, okay, dl over dt, which is equal to sum over I or I cross Fi external plus sum over Ij such that I is not equal to j, and we have Ri cross Fij internal. This is my equation, let's say equation number 5. Now here I will consider this term first. So consider the second term on the right hand side. The second term is sum over Ij such that I is not equal to j. We have Ri cross Fij internal. Now before solving this term, I will consider a special case here. I'll consider again the same sum over Ij such that I is not equal to j, and I consider two quantities, one is xi and the other is yj. This is same like this, Fij, Ri cross Fij. Now here I consider I values to be 1 over 2 and j values to be 1 over 2. Then this summation will give us, if I take I is equal to 1, so we have this summation over j, and I is 1, so x1 yj plus x2 yj. Now if I apply, first I apply the sum over I, so I values is starting from 1 to 2, so here we have x1 x2, and then yj is without changing, and next I will apply this sum over j, so we have x1 y1, if I consider j is equal to 1, and then we have plus x2 y1. Next I will apply this value of the j, so which is equal to plus x1 y2 plus x2 y2. But we know that I is not equal to j, so it means that this term x1 y1 and x2 y2 are not included in this summation because we have this condition. So this implies that x1 y1 and x2 y2 are not included because I is not equal to j. So we left with x1 y2 plus x2 y1. So this I can be written like this, sum over I j so we have these two terms now, x1 y2 and x2 y1. Now similarly if I will write it here. Similarly, if we have like this term sum over I over j or I cross Fij, okay, such that I is not equal to j. I have this term, then I can write it like this, sum over Ij, okay, and then we have Ri cross Fij plus Rj cross Fji. Okay, because if we look at here, we have x1 y2 and then x2 y1 and then x2 y1. So similarly Ri Fij, then we have Rj Fji, because we have to replace, because x1 then we have y2 here, then x2 then we have y1. So if this is Ri, then this will be Rj. If this is Fij, then this will be Fji according to this rule. And we know that, so the summation was like this, and we know that Fij is equal to, according to Newton's third law, the force acting on ith particle due to jth particle is equal to the force acting on jth particle due to ith particle, but they are opposite in direction. So it means that I can replace this Fji, this implies that I can replace this Fji by minus Fij. It's the same thing, like these two forces are equal in magnitude but opposite in direction. So my this term, which is sum over Ij Ri cross Fij internal, okay, which will be equal to sum over Ij, okay, we have Ri cross Fji, Fij, sorry, Fij, and then we have Fji. Fji, I will replace it by minus Fij. So if there is a minus, then this plus will become minus, and we have Rj. So instead of Fji, I will use Fij. Now Fij is common in both these terms, so I will keep it outside. I can take it outside. So our last equation, which is I sum over Ij Ri cross Fij internal, okay, will be equal to sum over Ij. Here we have I is not equal to j, but here we don't have this condition, because we already excluded from here, because we already excluded I already excluded here, okay. So we have only these terms, so on this side we don't have this condition, so this is without this condition. Now we have Ri minus Rj cross Fij internal. This is cross product, so these are the vector quantity and we have this internal, okay. Now what is Ri minus Rj? Ri is the position vector of ith particle and Rj is the position vector of jth particle. Suppose like we have a system of particles, okay, here we have a system of particles, okay. Let's suppose this is the ith particle, okay, and this is the jth particle. Then this will be the vector Ri, okay, and this will be the vector Rj. That is the position of the ith particle from the origin, okay, which is represented by Ri, and this is the position Rj is the position of jth particle from origin, so we represent it by Rj. Then Ri minus Rj will be this one. This is this plus this will give us Ri. So this is Rij, which is equal to Ri minus Rj. this is this vector Ri minus Rj is this vector, and I call it Rij as single name Rij. So here it means that I will replace this term Ri minus Rj by this Rij. So this equation will reduce to some more Ij such that I is not equal to j, and we have Ri cross Fij internal, which is equal to some more Ij. Now this Ri minus Rj, I replace it by Rij. Okay, and then we have cross Fij. Now this is the final expression. Now we have to simplify this equation. I will simplify this equation. Now suppose that we have a force which is basically called central force. What is a central force? First I will define that one. A central force is basically the force which is acting along the line joining the two particles. Like suppose we have two masses, okay? One is mass m1 and one is mass m2. Then these two masses, according to Newton gravitational law, these two masses attract each other, okay? And the force of attraction is along this line. If we have two charges, equal charges, let's suppose this is plus q and this is also plus q, then these four charges repel each other with a force which is called Coulomb force, okay? And the force of repulsion is along this line. So it means that after repulsion this particle will move in this way and this particle will move in this way. Similarly, if we have opposite charges, let's say this is plus q and this is minus q, then there is a force of attraction. There is a force of attraction between these two particles. So this particle, like this minus q attract this plus q towards itself, and this plus q attract minus q towards itself, and the force of attraction is along this line, the line which joining these two particles. So after force of attraction, this particle will move in this way and this particle will move in this way. Somewhere the two particles will combine with each other. Such kind of force is called central force. So it means that the force, this central force is either, this is the vectors, okay? This is the vector r, or the distance between the two particles. So this force is either parallel to this r, or this force is either perpendicular to r, this central force. So if I say that if Ij internal is central force, if it is the central force, this is the central force, then this if Ij internal is either parallel to this position Rij, because I already mentioned it here. So this central force will be parallel to this position vector Rij, or it will be parallel or anti-parallel. Either the force is in this way, parallel or anti-parallel, sorry. Force is parallel to r, or force is anti-parallel to r. it will be anti-parallel to Rij. If force is parallel to Rij, then the angle between force and Rij will be 0. If the force is anti-parallel to Rij, then the angle between force and this distance will be 180 degree. In both the cases, either parallel or anti-parallel, the cross product Rij cross Fij will give us 0, because the cross product, from the cross product we get sine, and sine of 0 or sine of 180 is always equal to 0. So it means that this term, the above equation, now reduced to sum over Ij Ri cross Fij internal will be equal to, now this central force, if this is central force, then it is parallel to this one, into parallel to this one. In both the cases the angle is either theta or 0. In both the cases the vector product of this Ri with Fij is equal to 0. So this term will become equal to 0. So I left it this one. Now my equation number 5. Equation number 5 is this one. Okay, this is equation number 5. Now we simplify this term, and from the simplification we got this term equal to 0. So I left with only with this one. So it means that this implies that equation 5 now reduced to what? N, which is equal to dl over dt, which is equal to sum over I Ri cross Fi external. Okay. Now the final expression is this one. I can write it as like this. I can write it here. N is equal to, now torque is basically equal to R cross F. Now, then the torque of ith particle will be equal to Ri cross Fi. Now this equation, look at this equation here, N is equal to dl over dt, which is equal to sum over I, and this Ri cross Fi is basically equal to Ni. Let's say this is equation number 6. Now this equation shows that the total torque on the system, okay, this equation shows that the total torque on the system of particle is equal to the vector sum of torque acting on individual particles. Like the total torque acting on the system is equal to the sum of individual torque of each particle. Okay, so this equation can be written as N is equal to the total torque on a system is equal to, if I expand this sum, then we have N1 plus N2 plus N3 plus up to Nn. So So the total torque is the vector sum of the torque acting on individual particle. Now if the torque acting on the system is 0, notice, if the total torque acting on the system is 0, then this equation will give us 0, n is 0, which is equal to dl over dt, or this implies that dl over dt is equal to 0, or this implies that L is equal to constant. Okay. So what it means? It means that if total torque acting on the system is 0, then the angular momentum of the system of particle is conserved, and this is called law of conservation of angular momentum. This is called law of conservation of angular momentum. So this was all about angular momentum of the system of particle. In the next video I will discuss a theorem which we call it I will prove a theorem which is related to the angular momentum of the system of particle. Thank you.